Artificial intelligence has finally cracked the code of Egypt's ancient hieroglyphs, revealing secrets that will shock you and change everything you thought you knew about our past. Hidden for thousands of years under scorching sand and guarded by dusty walls, these messages now speak of lost wisdom, forgotten rituals, and surprising truths about human life on Earth. Witness how digital sleuths have unraveled puzzles carefully inscribed by ancient hands to expose mysteries that could completely rewrite the history of humanity. The trailblazer who decoded hieroglyphs. Jean-François Champollion is widely celebrated for decoding ancient Egyptian hieroglyphs about 2 centuries ago, and his contribution stands as one of the most pivotal breakthroughs in archaeological study. Hieroglyphs had puzzled scholars for ages, and many people attempted to interpret those symbols without success. The discovery of the Rosetta Stone provided the main clue linking Greek, Deotic and hieroglyphic texts, which gave Champollion the basis to form solid translations. After years of research, he revealed his findings in 1822. Forever altering our view of ancient Egypt before Champollion. Other researchers like Thomas Young had tried to decode parts of the script, but they never achieved a complete understanding. Champollion's knowledge of Coptic, which evolved from the Egyptian language, proved vital. By comparing signs and phonetic clues, he unlocked a system that combined both phonetic and symbolic elements. That discovery opened the door to reading temple carvings, tomb writings, and countless papyrus documents, shedding light on ancient beliefs, history, and culture. The year 2022 marked 200 years since Champollion cracked the code, and researchers celebrated by reflecting on how it changed our approaches to archaeology. This bicentennial highlighted the universality of his achievement, reminding modern historians that perseverance, linguistic expertise, and cross-disciplinary study can solve big puzzles. More than just a name in textbooks, Champollion influenced how we see hieroglyphs as a living language that could be pieced together through careful comparisons. His work sparked countless digs and new academic fields. After this major decipherment, scholars gained the ability to read inscriptions on statues, temples, and everyday objects. This advantage led to big strides in Egyptology, giving us insights into royal lineages, religious practices, and social structures. Ancient beliefs around creation, the afterlife, and the nature of gods became clearer. Moreover, details about agriculture, trade, and laws emerged from records once locked behind mysterious symbols. Champollion's efforts did not just solve a puzzle. It revealed thousands of stories that had been hidden for millennia. Looking beyond the initial breakthrough, many researchers believe Champollion's legacy lives on in every new text we decode. Today's technologies, including artificial intelligence, build upon the methodical approach he championed: careful comparisons, an eye for detail, and lots of cross-referencing. Artificial intelligence and ancient writings. Artificial intelligence has become a game-changer in uncovering the secrets of ancient writings. Researchers now rely on systems like Google DeepMind to speed up translations and detect patterns that may be buried in unreadable manuscripts. DeepMind uses deep learning approaches that mimic how our brains process information, but it does so with vast data sets, letting it make connections traditional methods might miss. With AI scanning thousands of tablets, scrolls, and inscribed stones, archaeologists can more easily unravel what people wrote centuries or millennia ago. For ancient Egyptian hieroglyphs, AI can sift through inscriptions in temples and tombs, identifying recurring symbols that might share phonetic or conceptual frameworks. Instead of spending years trying to decode chipped, faded, or incomplete carvings, a well-trained AI system can propose likely matches in hours. Researchers can then review those suggestions and refine them further. This process takes advantage of pattern recognition at a scale never before possible, breathing life into scripts that once seemed beyond saving. One major benefit of using AI is how it can handle incomplete or damaged sections of text, predicting potential words or symbols based on context from other sources. This ability is especially helpful for languages that lack modern descendants like Sumerian or some forms of ancient Aramaic. By comparing grammar structures, known word lists, and available translations, AI can suggest ways to fill in the blanks, giving us a more complete view of how these languages worked and what the original text tried to say. Projects focusing on cuneiform tablets highlight how quickly AI can handle massive archives. Historically, entire lifetimes were spent trying to decode small sets of clay tablets because each symbol could have multiple meanings. Now, advanced algorithms can compare thousands of texts, spot usage patterns, and tag partial translations. This helps experts see how kings recorded taxes, how scribes wrote religious myths, or how merchants tracked sales. It's a powerful tool for bridging ancient and modern worlds. Along with translation tasks, AI assists in analyzing the context of discovered artifacts by linking inscriptions with geographical data and trade routes. Flexible machine learning models can show patterns in ancient migrations or economic exchanges. Researchers can test hypotheses about cultural diffusion, warfare, or environmental impacts on societies in ways that older methods made very difficult. As AI techniques refine, the hope is that long-lost stories will emerge more vividly than ever. Incredible. Revealing ancient scrolls with modern tools. One of the most amazing uses of new technology is in reading extremely damaged scrolls, especially those from Herculaneum near Pompeii. These scrolls were originally stored in a luxurious villa, but the Mount Vesuvius eruption in 79 CE buried them under ash. Over time, they hardened into lumps of charred material that seemed impossible to open. Early investigators often damaged the fragile texts while attempting to peel them apart, leading to losses. Today, specialized scanning devices and advanced analysis have made progress possible. High-resolution X-ray imaging allows experts to see inside the rolled scroll without physically unwrapping it. Then machine learning software can detect subtle variations in the material, pinpointing where ink might still exist. This digital unrolling method has allowed partial readings of philosophical treatises and literary works that had been locked away for centuries. While the process is delicate and not every scroll yields its entire text, the breakthroughs represent a significant improvement over older attempts at mechanical separation. This approach could also be applied to ancient Egyptian papyri that have deteriorated. In some cases, fragments have been found in burial wrapping or stuffed inside animal mummies. Their brittle condition makes them very risky to handle. Computational imaging can help by reconstructing torn sections and enhancing faded characters, giving epigraphers a clearer sense of the original wording. The synergy between physical archaeology and computer-driven analysis is revolutionizing how we salvage texts that might otherwise have disintegrated beyond preservation. Researchers often learn about everyday life from these texts. Some scrolls detail personal letters, business transactions, or medical knowledge, giving us real glimpses into how people live. Others harbor philosophical ideas or even recipes for pigments and potions. By systematically examining each inscription, AI can group them by topic or date range, offering patterns that might not be obvious at first.